And now, here's Ozzy.
Back in Ozzy's day, the camera was strictly an optical mechanical device. The recording method was film. You control the quality of the recording by selecting the film you use, depending on whether you wanted black and white or color, the amount and temperature of the available light, and if you are projecting or printing the final image. In the digital world, the camera and recording medium are combined. So today, there are additional considerations when you try to put together a best camera recommendation. Let me say from the start that I've structured this video around the camera and lens features that I think are most functional for photographing scale models. I simply can't recommend any one specific camera because the choices are just too many and ever-changing. However, there are online resources that provide helpful comparative information on the various current cameras and lenses. Two of my favorites are DP Review and Fred Miranda. It can be difficult to categorize cameras today as manufacturers continually mix form and features to broaden appeal to wider markets. But roughly speaking, digital cameras fall into some basic types. Small compact cameras, cameras that resemble a DSLR but without interchangeable lenses. These cameras are sometimes referred to as bridge cameras. Actual DSLRs, and these are the digital equivalent of a 35mm SLR, mirrorless interchangeable lens cameras, and a variety of medium format cameras. While you can use any of these to record an image, some of these have features that allow you to achieve better results. At the top of my feature list is the ability to use interchangeable lenses, so for me, I can quickly eliminate the compact and bridge cameras as possible best choices. Likewise, medium format digital cameras are simply not practical for a number of reasons. This reduces my field of choices to either a DSLR or a mirrorless with interchangeable lenses. So what's the difference between a DSLR and a mirrorless? With a DSLR, you traditionally frame and focus your image through an optical viewfinder. Light comes through the lens, is reflected off of a beam splitter mirror, bounces around a mirrored prism, and then finds its way into the eyepiece. If you use the autofocus function, the camera uses a separate autofocus sensor that gets the image from the light passing through the beam splitter. When you actually take the picture, the mirror flips up and the shutters trip. If the DSLR is capable of live view shooting, the mirror flips up while you use the actual image sensor and LCD screen on the back to frame and focus. With a mirrorless camera, the light passes directly onto the image sensor, which is used for direct framing and focusing. If the camera is equipped with an eye-level viewfinder, the image in the finder is actually a small digital display. Precise focusing is key when photographing scale models. Because depth of field is so shallow with our small subjects, there isn't much room for error. I'll go into this further in the next video, but as it applies to the choice of a camera, it means that we'll get the best results when we can actually manually focus on the actual image sensor. Trying to rely on the autofocus can be hit or miss, so in the end my choice of camera is going to be a DSLR that can shoot in live view or a mirrorless camera. The next must-have is a good image sensor. Here's where you come to grips with the fact that all pixels aren't created equal. Sensors come in a variety of sizes and architectures. Most all the current high-end cameras use an image sensor that's known as a full-frame sensor. This means that the sensor is the same size as the image on a 35mm negative. This type of sensor is capable of the best performance of the ones that I'm showing here, and something you might want to consider if your final images will be large. Since I'm pretty much focused on the web, I gave up my requirements for a full-frame sensor. A more common sensor size is the APS-C. This type of sensor is also termed a crop sensor. The reduction in size is expressed as a crop factor. Typically this is 1.5, but Canon uses 1.6, and there are some 1.7s as well. The area of a 1.5 crop is 0.666 the area of a full-frame sensor. The reduced area of the crop sensor means that the pixels are smaller, and the images typically exhibit more high ISO noise than from a full-frame sensor. This is pretty much a non-issue for my use because I rarely ever shoot above ISO 200, and my finished images are relatively small. One advantage to us as modelers is that the small sensors offer a greater depth of field. However, there's a limit to how small the sensor can be and still produce an acceptable image, which is why images taken with phones and ultra-compact cameras don't hold up well when viewed on anything larger than an 8-inch display. The architecture and structure of sensor design has many permutations, but sensor performance is a key element when choosing a digital camera. Sites like DP Review publish test patterns where you can select the same images from different cameras to compare performance. I always look for a clean, low-noise image with good resolution, and always check to see the low-light performance. I can't say it's foolproof, but it gives you a pretty good idea of the starting point for evaluation when deciding what camera to purchase. The sensor isn't the only new bit of the digital world. The firmware that runs the camera is equally important for maximum performance and functionality, and I'll be talking about the specifics throughout this series, but I would encourage you to download the manual for any camera that you're considering, so you can survey the menu system and review functions and customizations that are available. Since the cameras that I've suggested have interchangeable lenses, what lenses would be a good choice? The first is what I think of as a general-purpose all-around zoom that ranges from around the 20s to the 120-135 millimeter range. This lens is the workhorse when you're imaging your entire model. My second must-have lens is a macro lens with a focal length of 100-205 millimeters. Macro lenses focus in much closer, usually at a 1-to-1 magnification, and that means that the image on the sensor is equal to the size of the object. I prefer to avoid short macro lenses like a 50 millimeter because the working distance is so close that it limits many lighting options. Macro lenses are your best choice for those close-up detail and construction shots. If your budget doesn't allow for a macro lens right off, there are a couple of alternatives. The first are magnification filters that screw onto the front of the zoom. Second are extension tubes that move the lens further out from the camera body. The tubes are a better choice because they eliminate any additional optical issues that might come along with the filters. However, neither of these alternatives offer the other big advantage of a macro lens, which is that macro lenses typically offer much smaller f-stops, like f32 or f36. Smaller f-stops are the key factor in improving depth of field. Also, generally speaking, macro lenses are better optically than standard lenses. When selecting any lens, my rule of thumb is there's no substitute for good glass, and glass and metal always trump plastic. One final note about focal length of lenses. Some lenses are designed to be used only on a crop sensor camera. In these cases, the field of view will correspond to the stated focal length. Likewise, lenses that are made for a full-frame camera will also function as indicated when used on a full-frame camera body. However, if you use a full-frame lens on a cropped camera, the result will be like using a lens with a longer focal length than the stated value of the lens. For instance, if you use a full-frame 50 millimeter lens on a camera with an APSC sensor, a sensor with a 1.5 crop factor, you'll only be seeing a portion of the actual field of view of the 50 millimeter lens. So the lens will function like a 75 millimeter lens. Now that I've covered some of the basics, I thought it'd be a good idea to go through the steps that I use to record an image, so you can get an idea of how the different elements of the camera and lens fit into the process. For the purpose of the present discussion, I'm avoiding other elements of the setup that I'll be discussing in future videos. Here, I really just want to demonstrate certain functional elements of the camera and lens that are important. In this example, I'm photographing a partially constructed 1/48 scale aircraft model with a typical DSLR. Since the model is pretty good sized, I'll be using the zoom lens. Once the composition and lighting are set, let's take a look at the camera and lens setup. First off, I want to minimize digital noise. So rather than allowing the camera to determine the ISO, I want to manually set the ISO. Here I'm changing the camera's ISO setting from auto to 200. Next, I want to help control the depth of field by making sure that the lens is stopped down. So I'll change the camera mode to aperture priority. This setting allows me to dial in the f-stop and let the camera set the shutter speed for proper exposure. The lens is set to manual focus. I shoot a gray card and set a custom white balance. I'll cover the details of this step in the video on color. Since I'm relying on the camera to set the shutter speed, I want to minimize any sort of camera movement. Even though the camera is securely mounted to a tripod, tripping the shutter manually will cause movement. Likewise, just the movement of the mirror in the DSLR will cause a certain amount of shake, so even using the timer still induces movement. To minimize any sort of camera shake with the DSLR, I always use the mirror lockup function. This allows the mirror to swing out of the way independently. To use the mirror lockup function, the mirror and shutter need to be controlled remotely. I typically use a simple cable release. The first press swings the mirror out of the way. You want to wait a few seconds for the camera to stabilize and then trip the shutter. If you're using a mirrorless camera, you obviously don't have a mirror lockup function, and you could do hands-off exposure with just the timer. The last thing I do before making the exposure is fine-tune the focus. Being able to fine-tune where you focus is key to managing depth of field, and I'll talk about the different situations in the next video, but for now, I want to address the hardware functionality. One huge advantage of digital photography is the ability to precisely focus directly from the information on the sensor. However, with a DSLR, this only happens when you're shooting in live view. I switch to live view, select the area of primary focus, maximize the image size, fine-tune the focus, exit live view and expose the image using the mirror lockup. I do a quick review of the image and, if necessary, adjust the exposure compensation. If your camera is capable of being tethered or remotely controlled with a large laptop or tablet, you have the luxury of even more magnification. Here I'm using the laptop to shoot in live view. The camera's software utility has been installed. I want to capture an in-progress image. To add some dynamic to the image, I'd like my hands to be visible. Using the software, I can position my hands, focus the camera, and expose the image right at my work area. Note that in this instance, I'm using the self-timer mode. I'll be going into the details behind all these steps in the subsequent videos, but I hope this information's given you some idea of what to look for when selecting a camera. Next time I'll be taking a look at several ways to maximize depth of field.